Okay, a function which can be differentiated by applying the formula, a function which can be differentiated by applying the formula is called is called a standard function, is called a standard function. Whereas if a function whereas if a function cannot be differentiated by applying the formula, then it is called a composite function. Then it is called a composite function. So please write down page number 203, page number 203, page number 203, question number 9. Okay, there are 16 sub questions. We have to do all the questions. Okay, so let us start with the first one. Everyone, look at the board. The question is x square plus 2x whole to the power 4. This is the question. So the first thing that you need to understand is the what do you call it? The nature of the question. It has to be an explicit equation. So we take it as let y equal to this. So y equal to x square plus 2x. Now it has become an explicit function. That means y is being expressed in terms of x. So y is your dependent variable and x is your independent variable. So what do? We differentiate with respect to x. Derivative of y, everyone knows, is dy by dx. Okay. Now look at the formula. Look at the power. The moment you see the power to be a constant, the moment you see the power to be a constant, it reminds us about the first formula. The first formula says whenever the power is a constant, the base has to be x. So we assume this as x. Is that clear? So what is the first formula, everyone? The first formula is d by dx of x to the power n equal to n dot x to the power n minus 1. So this formula will help us differentiate any algebraic expression. Is that clear? So whenever the power is a constant, everyone, you need to keep in mind whenever the power is a constant, the base has to be x. So since the base is not x, we have assumed this as x. So 4 comes in front. So 4 comes in front. According to this formula, the power comes in front. The base remains as it is, x square plus 2x, and n minus 1, that is 4 minus 1 is 3. So this is the formula. But since this is a composite function, the part which you have assumed as x has to be differentiated one more time. The part which you have assumed as x has to be differentiated one more time. That means this is the part which we have assumed as x. So you are going to get d by dx of x square plus 2x. So this is how you differentiate a composite function. Everyone, what you need to do is you have to compare the function with the formula that you know. If it can be differentiated by applying the formula, then it is called a standard function, no assumption required. But if it cannot be differentiated by applying the formula, then we have to assume it as x and then apply the formula, and the assumption which you have made is to be differentiated one more time. So see, 4 open bracket x square plus 2x whole to the power 3 remains as it is. I need to differentiate this. Look at this. Derivative of x square. The power is a constant. The base is x. That is absolutely correct. So it is a standard function. So your 2 cards answer comes in front. So you get 2 comes in front. X 2 minus 1 is 1. Is that clear? Plus 2 is a constant. So comes out and derivative of x is 1. So this is how you differentiate a composite function. So look at the solution properly, everyone. So this is question number 9, subdivision 1. We will be doing a lot of questions of this form. So for the first, this is the first question, 9 subdivision 1. Okay, so see how I have done it. Once again, there are very limited variations that you have to keep in mind. The first variation is whenever the power is a constant, the base has to be x. Then only I can use the first formula. And to use the first formula, the power comes in front and you subtract 1 from the power. Is that clear? If the base is x, it is a standard function. If the base is not x, then it is called a composite function. So please take a screenshot of this, everyone. So please take a screenshot of this. So if you understand this composite function properly, then you will have no problems in derivative. Is that clear? All are related. So I'll just rub this. So yeah, I hope you have taken a screenshot of this. So I will solve few more examples of this form. Okay. So the formula that I am using is d by dx of x to the power n equal to n dot x to the power n minus 1. So this is the first formula, and this is applicable for an algebraic function which says if the power is a constant, the base has to be x. If the base is x, the power comes in front and you subtract 1 from the power. That is the formula. But if the power is a constant and this properly, sine to the power 5x can be written as sine x to the power 5. Now look at this derivative to write differentiating with respect to x. I've already explained in the first class that whenever you come across an explicit function, y on the left, x on the right, we always differentiate with respect to x. So what do you pay attention? The power is a constant. So look at this. If the power is a constant, the base has to be x. The power is a constant, but the base isn't x. Is that clear? This is sine x. So this is called a composite function. So what do? We assume this part as x. So I'm using a different colored marker. So we assume this part as x. So when we assume this part as x, then we can use this particular formula. What is going to happen to 5? 5 comes in front. So you get 5 comes in front. 5 open bracket sine x. 5 minus 1 is 4, but this is just an assumption. So d by dx of sine x. The part which we have assumed circled has to be differentiated once. The reason is this is the formula only if the base is x. But since the base is not x, so this is called a composite function. Is that clear? So help me. Formula. It's a direct formula. What's the derivative of sine x? What's the derivative of sine x, please? The derivative of sine x is formula number 6. Derivative means we are breaking the function. So derivative of sine x is nothing but cos x. Derivative of sine x is nothing but cos x. So this was regarding the first formula. This was regarding the first formula. Okay. So, so you can take a screenshot of this. So I'm going to do a next question. So next question is, everyone, next question is y equal to x square plus sine x whole to the power 7. So again, look at this. Y is being expressed in terms of x. So we write differentiating with respect to x. Derivative of y is dy by dx. Now look at this. If the power is a constant, formula number 1, it will always be applicable. So if the power is a constant, the base has to be x. But instead of x, it is x squared plus sine x. So this part becomes the composite part. So if this part we assume as x, what's going to happen to 7? 7 will come in front. 7 open bracket x squared plus sine x. 7 minus 1 is 6. But this is just an assumption. So d by dx of whatever you have assumed as x, that has to be differentiated, not the entire thing. Not the entire thing. Okay. So what do you get? Your final answer 7 open bracket x square plus sine x whole to the power 6. You know, look at this. The power is a constant too, and the base is x. That means this is direct formula. That is, it's a standard function. Because didn't I tell you, if any function can be differentiated by applying the formula, it's called standard. So no assumption required. So the derivative of x square, you know, if the power is a constant, the base has to be x, and it satisfies. So 2 comes in front. No assumption. So 2 comes in front. X 2 minus 1 is 1. Done. Plus differentiator composite function. Okay. So these were the 3 questions for the first formula. Now we are going to move on to the next question. So please take a screenshot of this. So all these questions are there in question number 9, page number 206. So the second formula that now which we are going to do is, everyone look at the board, d by dx of e to the power x. So differentiation of an exponential function will always be e to the power x. differentiation of an exponential function will always be e to the power x. Okay, but if the question is, look at the board, y equal to e to the power ax square plus bx plus c, then there's no formula for this, because to use the formula the power of e has to be x, isn't it? So this comes under composite because we don't know the derivative of this particular function. So how do I do it? Y, don't forget to write differentiating with respect to x. Differentiation of y is dy by dx. Now see, assume this part as x. Okay, so if you assume this as x, then e to the power x, the formula will be e to the power x itself. The formula will be e to the power x itself. But this is, since this is an assumption, so dy dx of ax square plus bx plus c. So what do you get? E to the power ax square plus bx plus c as it is. Now differentiate this. A is a constant. If a is alone, then the derivative of a is 0. But it is with a variable. It is with x, isn't it? So if the power is a constant, the power comes in front. So 2 comes in front. So you get 2x, 2 minus 1 is 1, plus b is a constant, comes out, derivative of x is 1, and finally the derivative of c is 0. So the derivative of e to the power ax square plus bx plus c is nothing but e to the power ax square plus bx plus c into 2ax plus b. So this is regarding the second formula that I had already taught you yesterday. This is regarding the second formula which we had already learned yesterday. Okay, now one more, a similar type of question. So can I rub this? Please take a screenshot of this particular question. So once I'm done, so please don't forget to take a screenshot. Okay. So based on this only, so I am teaching you the difference between a standard function and a composite function. If you understand this properly, then trust me, derivative is going to be very easy for you all. Okay. So the next question that we are going to do is, let us see, y equal to e to the power sine x cube. Now I need to differentiate this. So look at this properly, huh? Okay. So you can easily see that this is an explicit function where y is being expressed in terms of x. So derivative, don't forget to write differentiating with respect to x. Derivative of y is dy by dx. Okay, so what is the power of e? What should be the power of e in order to use the standard formula? The power of e has to be x, isn't it? But what do you see? This is sine x cube. So what do? We assume this part as x. So derivative of e to the power x is what? E to the power x, e to the power x. But this is just an assumption. So d by dx of sine x cube. Next, e to the power sine x cube has already been differentiated. You keep it as it is. Now it's time to differentiate this. Now ask yourself the same question. Do I know the derivative of sine x cube? Formula number 6 says differentiation of sine x is cos x. Differentiation of sine x is cos x. This is the formula number 6. Okay, so just compare this. In order to use the formula, the angle that has to be with sine is x, but this is x cube. So there's no formula for this. So in order to convert this into this x cube part has to be assumed as x. So derivative of sine x is cos x, cos, say x, but write down the value of x. But this is just an assumption. So d by dx of x cube, d by dx of x cube. So what do you get? E to the power sine x cube into cos x cube, differentiation of x cube. Remember what I told you? Whenever the power is a constant, formula number 1, the base has to be x, and the base is x. So no assumption required. That means this is a direct, this is a standard function. So what is the derivative of a standard function? What is going to happen to 3? Because I've already told you differentiation means we are breaking the function. So what's going to happen to this 3? 3 will come in front. So 3 is going to come in front. So you get 3 comes in front. So x squared. So this is the derivative of e to the power sine x cube. So this time, everyone listen to me. You are bound to get one question where they will tell you to differentiate a composite function. That means they will give you one question, and this particular answer will be given in as the 4 options. So you have to select one of them. Okay. So this is regarding the second formula. This is regarding the second formula. So I hope you understood. Once again, let me revise. Formula number 1 says whenever the power is a constant, base hunu parcha x. If the base is x, no problem, apply the formula. That means the power comes in front and you subtract 1 from the power. But if the base is not x, then that becomes your composite function. Okay, formula number two says if the base is e, the power has to be x. If the power is x, well and good, apply the formula, it is e to the power x. But like in this case, the power is not x, so we have to assume it as x. And whatever part you have assumed, you have to differentiate it one more time. Is that clear? So this was regarding the second formula. So I'm going to teach you the for all the formulas. Okay. So I guess these two formulas are also done. Formula number two, e to the power x. Formula number six, sine x. Now we move on to the third formula. Now we move on to the third formula. The third formula is d by dx of a to the power x is equal to a to the power x into log a. That means if the base is a constant, the power has to be x. Keep that in mind. So look at this particular question. If someone tells you differentiate this 7 to the power x square plus 7. So what you are going to do is you are going to look at the base, and you are going, once you look at the base, you see that the base is a constant. So this will remind you of formula number 3, which says if the base is a constant, then the power has to be x. Is the power x? No. So we assume this as x. So derivative of y, dy by dx equal to, if the power is if the base is a constant, the power has to be x. That means this is a to the power x formula. So what is a to the power x formula? If the power would be x, but since the power is difficult, so I hope by now you're understanding what composite function basically means. It means that if the function cannot be differentiated by applying the formula 2x plus 2 derivative of 7 power x, 7 to the power x square plus 2x, 7 to the power x square plus x square plus 2x. Okay, so just go through this. I think the blue is not working. I'll just get one black marker. Okay. I hope you all are being able to see the whiteboard. No problem now with the audio. Anyone, please? Okay. So, so another question. The question is y equal to log 3x plus 7. Y equal to log 3x plus 7. Y equal to log 3x plus 7. Okay. Y equal to log 3x plus 7. So the moment you see log, you are going to remember the third formula, that is d by dx of log x, is equal to 1 by x. So how does log gets broken? You get 1 by x. So everyone look at the board. Don't forget to write differentiating with respect to x. Y code derivative, everyone knows it is dy by dx. So look at this. Do you know the formula for log 3x plus 7? No, because the formula is only for log x. So this is a composite part since we don't know the formula for this. So I have to somehow apply the formula. So in order to apply the formula, I have to assume that the one of the term is x. That means log should always be with x, isn't it? So what do? I assume this part as x. So if this becomes x, then derivative of log x is 1 by x. So see, write down 1 divided by x is this 3x plus 7. This would be the formula if this was x, but this isn't x, isn't it? So we have to differentiate what you have assumed, that is 3x plus 7. So what do you get? 1 divided by 3x plus 7 into 3 is a constant, comes out derivative of x is 1 and derivative of 7 is 0. Why? Because differentiation of a constant is 0. So what do you get, everyone? 3 plus 0 is 3. So 3 ones are 3 divided by 3x plus 7. So this is how you differentiate a composite function, everyone. This is how you differentiate a composite function, and this is log, and this is log. So I'll do few more questions where we have to use log. And the best part about this derivative is the same variations keep on coming. That means the first formula, that is if the power is a constant, the base has to be x. The second formula, if the base is e, the power has to be x. And the third, if the base is a constant, the power has to be x. And this is the fourth one. Okay, so let us do another question. Look at the board. Y equal to log sec x plus tan x. Y equal to log sec x plus tan x. I need to differentiate this. So could you please help me out? You know, derivative of y is what? Dy by dx. Dy by dx is equal to now again, do you know the formula for log sec x plus tan x? No, because there's the moment you see log, it's a logarithmic function and it has only one formula, and that is log should always be with x. So what we need to do is we need to assume this entire thing as x. So derivative of log x becomes 1 by x, that is sec x plus tan x, but this is just an assumption. So d by dx of sec x plus tan x, sec x plus tan x, whatever you have assumed, you need to differentiate that. So next, what do you get? 1 by sec x plus tan x, 1 by sec x plus tan x, 1 by sec x plus tan x. Okay, 1 by sec x plus tan x. Okay, 1 by sec x plus tan x. I need to differentiate them. There's a plus sign, so I have to differentiate one after the other. So derivative of sec x is formula number 11, sorry 9. What's the derivative of sec x? Sorry, 10. Derivative of sec x will be sec x into tan x plus derivative of tan x is sec square x. So 1 divided by sec x plus tan x. What is common out here? Sec x is common. So when you take out sec x, what is left? Tan x plus, there were two sec. So if I take out one, one is left. So look at this, sec x plus tan x and tan x plus sec x. It's same. Whenever there's a plus, the order does not matter. So when you cancel this and this, the answer is sec x. So you will get this question to differentiate, and there'll be four options, and out of the four options there'll be one option which will be sec x. So simplify it, get the answer and tick that. Is that clear? So that is how you are going to get questions from for this year's first sem MCQ types. Not difficult. I hope you all can see the whiteboard. Can you see the whiteboard? Yes or no?
Yes, sir.
Yes, sir. Okay, Kashish. Okay, you're fine. So, So this is how it is to be done. Okay, so this one was regarding log. Now let us do few questions where you have to differentiate, where we have to assume two times or even three times. Okay, so everyone look at the board. Suppose the question is y equal to under root sine x cube. So this is the question, y equal to under root sine x cube. So the moment you see root, you must realize that it's a question on an algebraic function. So the formula that you need to understand is d by dx of root x. So what is the derivative of root x? It is 1 by 2 root x. So if there is a root, square root, then the inside part has to be x. So what do? We assume this part as x. So derivative of y is dy by dx equal to, if this is root x, then the derivative of root x is, see the formula, it is 1 by 2 root x, that is 1 by root sine x cube, but this is just an assumption. So d by dx of sine x cube. Next, 1 by 2 root sine x cube. I've already differentiated this, so you do not do anything with this. Now look at this. Formula number 6 says derivative of sine x is cos x, but this is sine x cube. This is sine x cube. So this is a composite function because we don't know the formula for this. The only formula that we know is differentiation of sine x cos x. So the angle has to be x, but this is x cube. So we assume this as x one more time. So you have to keep on assuming till you don't get a standard function. So sine x को derivative की रही cos x. So it's going to be cos x, but this is just an assumption. So d by dx of x cube. So what do you get? Cos x cube divided by 2 under root sine x cube into derivative of x cube. Formula number 1, everyone. If the power is a constant, the base has to be x, and it is x. So no more assumption. This is direct or standard function. So what's going to happen to this 3? 3 already answer. So what will you get? You are going to get 3 comes in front and you get x squared. So this is how you differentiate a function which had to be differentiated 2 times by assumption. 2 times by assumption. 2 times by assumption. Okay. Now next question. So I'll rub this. Next question. These are all questions from question number 9. Whatever questions are left, I want you all to complete those. Is that clear? So the question is y equal to cos open bracket sine x cube. So this is one derivative. So the question could be, if y equal to cos open bracket sine x cube, find dy by dx. 4 options are given, so you have to find out the correct option. So everyone, look at this. The moment you see cos, you must realize that it's a trigonometric function. So 1 2 3 the phaida sine. So directly trigonometric function is from formula number 6. So this is cos, so we are talking about formula number 7. So d by dx of cos x is minus sine x. So when you break cos changes to minus sine. But in order to use this formula, the angle that has to be associated with with cos is x. But यहाँ तक कोनी के छ, so we assume this part as x. So derivative of y is dy by dx. ल त cos x को डेरिभेटिभ के रहेछ minus sin x. So minus sin x भन्नुको मतलब the part which you have assumed. That's why I want you all to circle it. Okay, sin x, but this is just an assumption. So d by dx of sin x cube. D by dx of sin x cube. Next, minus sin open bracket sin x cube into, now look at this is sin x cube. Look at formula number 6. It is sin x co derivative. Sin x co derivative is cos x, but this is x cube, so this part has to be assumed as x. So what is the derivative of sin x? It is cos x, but again this is just an assumption. So d by dx of x cube. So the final answer, minus sin open bracket sin x cube into cos x cube dot derivative of x cube. What's going to happen to this 3? 3 comes in front, so you get 3x square. So this is how you differentiate a composite function, everyone. So this is the first part, and this is differentiation of a composite function. So take a screenshot of this. So I'm going to drop this. Okay, now we move on to, so question number 9, whatever questions are left, I want you all to do those questions. Is that clear? Now we move on to question number 10. Question number 10, this is page number 203, same. Now I'm going to teach you how to apply the formula along with property. So question number 10, subdivision 3. So question number 9 was all about only one function. So we just had to apply the formula. But the moment you come across two function, property chalaunu parcha la. So y equal to x square sine 1 by x. So this could be one MCQ type. So li differentiate gara vanere. Oh, so the problem is there are two functions. So whenever there are two functions, I have to use product rule. So the first one becomes your u and the second one becomes your v. So the rule is dy by dx is equal to, I'll just write down the rule. The rule is u as it is, differentiate v, second one. Now you keep v as it is, differentiate the first one. So please substitute the value. What is u? U is x square, d by dx of what is v, that is sine 1 by x, plus sine 1 by x as it is, into d by dx of u, what is u, that is x square. See properly, okay, because some of the students tend to get confused out here. There is nothing to get confused out here. So as you can see properly, as you can see properly that as you can see properly that one term has been kept constant, differentiate the second. Now the second term has been kept constant, and you differentiate the first term. So now it's time to apply the formula. So this is property. So once you apply property, the next step would be applying the formula. So x square as it is, I need to break this function sine 1 by x. Ask yourself a question, do I know the derivative of sine 1 by x? Then the answer would be no. Formula number 6 says derivative of sine x is cos x. So in order to use the formula, the angle of sine has to be x, but this is 1 by x, so we assume this as x. So derivative of sine x will be cos x, but this is just an assumption. So d by dx of 1 by x plus sine 1 by x. This you are not going to apply the formula because we are not breaking the function. When you see d by dx, that means you are breaking the function. Now d by dx of x square, x means algebra, formula number 1, x to the power n. That means if the power is a constant, the base has to be x, and it absolutely satisfies the condition. So this is formula number 1. What's going to happen to this 2 comes in front, so you get 2 into x. And please don't make the mistake of cancelling these two, because this is a trigonometric function and this is an algebraic function. Okay, so now we move on to the last part. So what do you get? X square cos 1 by x, and you know the derivative of 1 by x, particular case number 3, which is derivative of 1 by x is nothing but minus 1 by x square. If you don't know this, please go through the formula which I had done in yesterday's class, online class. So x square and x square gets cancelled, so your answer is minus cos 1 by x plus 2x into sine 1 by x. So the formula, this is the simplified value of the given function. So in the first part you learned how to differentiate a composite function, and in the second part you learned how to apply the formula, but before that we need to apply the property. And how do you come to know that I have to use property? Whenever there are two functions being multiplied or divided, then only we use this particular property. This is called product rule. Please take a screenshot of this. Please take a screenshot of this. And now I'm going to do quotient rule. Okay, I'll drop this. Okay, now I'm going to do quotient rule. Now I'm going to do quotient rule. So see, quotient rule, y equal to x square plus 3 divided by what was it, x cube plus 2x at x equal to 1. So this was the question, and four options will be given. That is x square. Okay, that is x square. That is x square. Okay, x square. So four options will be given. You have to you have to identify the right option. So for that, since there is a division sign, we are going to use quotient rule. Okay, those who are doing quotient rule for the first time, please look at the board. Differentiation of y is going to be what? Dy by dx. So this is going to be u and this is going to be v. Quotient rule, u by v rule. The property says whenever there's a division sign, before you apply the formula, you have to apply the property. The property says denominator square, keep the denominator constant, differentiate the numerator, that is u, minus, now you keep the numerator constant, and then you differentiate the v. It is same like product rule, keeping one fixed and differentiating the other, but for a quotient rule there is a minus sign. Is that clear? Now just substitute the values. What is v? V is the denominator, that means x cube plus 2x. What is u? D by dx. Or what is u? U is x square plus 3 minus x square plus 3 as it is, d by dx of v. What is v? X cube plus 2x, divide the whole thing by x cube plus 2x whole square. And one important thing which I want to tell you is, some students differentiate this also. Do you see d by dx anywhere around this value? No. So if you don't see d by dx, there is no point differentiating the function. Is that clear? So wherever you see d by dx, you differentiate there only. Like for instance, in this particular expression, x cube plus 2x, we don't have to break this function, so keep it as it is. Now I need to differentiate this. X square, what's going to happen to this 2 comes in front, so you get 2x, done. And derivative of 3 is 0, so no use writing it, minus again x square plus 3 as it is, because you need not break this. Wherever you see d by dx, there only you have to apply the formula. Now I need to break this. 3 comes in front, so you get what? 3x square plus 2 is a constant, comes out, and derivative of x is 1, so 2 ones are 2. divide the whole thing by divide the whole thing by x cube plus 2x whole square. So since all the derivative d by dx has vanished, now it's time to put the value of x. Now put the value of x. What do you get when you put the value of x? You can do it mentally. 1 cube is 1, 2 ones are 2, 2 plus 1 is 3, 2 ones are 2, minus 1 square is 1, 1 plus 3 is 4, 3 ones are 3 plus 2 is 5. Divide the whole thing by 1 cube is 1, 2 ones are 2, that is 3 square. So what would be your right answer? 3 twos are 6, 5 fours are 20. So 20 minus 6 is minus 14, divided by 9 would be your correct option. Is that clear? So once you understand how to do these again and again, then these are the steps you can totally ignore. Like, see, I had to explain, that's why I had to write down the quotient property, then I had to substitute u and v. So once you get used to it, these two steps will vanish. That's why this will you can do it in a much easier way, faster way. Is that clear? So you can ignore this property, you can ignore this property. So directly you are going to write with x cube plus 2x, differentiation of this is 2x, minus this will remain as it is, and differentiation of this. So directly from here, two steps. That is why it's a 2 mark question. Is that clear? So this was basically done to explain it to you. Once you have understood this, from next time if I tell you to use quotient rule, you can ignore these two steps and directly get the answer by using these two steps only. Is that clear? So this is regarding quotient rule. So you understood product rule also, you understood quotient rule, you understood how to differentiate a composite function. Before I forget, I want you all to do question number 9, subdivision 1 to 16. There are 16 questions, and out of which most of the questions have been done, like around 10 questions have been done. Okay, so but I still want you all to try those questions again, because if you understand that properly, then that is the basics, like ABCD of calculus. So if you have no problem understanding that, then the topics to follow will be very easy for you. Okay, so this is the quotient rule. This is the quotient rule. Now we come to differentiation of trigonometric function. So if you see a trigonometric function and if you use the normal process, then there is maximum chances that you will not get the answer and the calculation is going to be long. So this is question number 11, subdivision 3. The question is y equal to under root 1 minus cos x divided by 1 plus cos x. So if you apply the normal method, then you know inside the root there has to be x. So we assume this part as x. Derivative of root x is 1 by 2 root x. But this is just an assumption. So this is division. So we use quotient root. The solution becomes long, lengthy. So whenever you come across a trigonometric function, the first thing that should come to your mind is I have to apply formula. So there are two formulas, one is called multiple and the other one is called submultiple. How do you identify? I'm going to just write down the formula for you. So sine 2x equal to 2 sine x cos x, that's the first formula. Second one is 1 minus cos 2x is 2 sine square x. Whenever it's minus, the formula will be plus, sorry, sine. And whenever it's plus, 1 plus cos 2x, the formula will be 2 cos square x. So these are the three formulas, and the angle which you see out here is 2x, 2x and 2x. So this is called formula on multiple angle. This is called formula on multiple angle. Is that clear? So please take a screenshot of this, because I'm going to change this formula into submultiple. So this is multiple. Okay, so for submultiple, what you simply have to do is you have to divide the angle by 2. So when you divide 2x by 2, 2 will vanish. So sine x equal to 2 sine x by 2 cos x by 2. Similarly, 1 minus cos 2x divide by 2, so the 2 will vanish. So 1 minus cos x will be 2 sine square x by 2. Again, 1 plus cos 2x divide by 2, 2 and 2 will vanish. So 1 plus cos x will be 2 cos square x by 2. So this is the formula for sub multiple angle. So this is the formula for sub multiple angle. Okay, so let me use this. Everyone look at the board. So y equal to under root, what is 1 minus cos x? Minus means sine, so it's going to be what, 2 sine square x by 2. What is the formula for cos? Plus, so it's going to be 2 cos square x by 2. So 2 and 2 gets cancelled. Y equal to under root, you know, sine square x by 2, cos square x by 2. Sine by cos is tan, and there's a square, so you get tan square x by 2. So the square and the root gets cancelled. The square and the root gets cancelled. So you are left with y equal to tan x by 2. Now isn't this easy to differentiate? Derivative of y is dy by dx. Derivative of y is dy by dx, and derivative of tan should always be with x, but this is x by 2. So we assume this part as x. Tan x derivative is sec square x, but this is just an assumption. So d by dx of x by 2. So your final answer, sec square x by 2, as it is. 2 is a constant, comes out. So if 2 comes out, there's nothing in the numerator, that means 1 dot. If 2 comes out, only x is left, and the derivative of x is 1. So the answer to this is 1 by 2 sec square x by 2. 1 by 2 sec square x by 2. So this is question number 11, subdivision 3, from page number 203. Now we'll do one more question, last question. So look at the board, please. Look at the board, please. So this is called a conjugate pair. Conjugate pair means the numbers are same, one is plus, the other one is minus. So this is called a conjugate pair. This is called a conjugate pair. So next, another important question. Whenever you see tan, so y equal to under root 1 minus tan x divided by 1 plus tan x. Now look at this. This is also a conjugate pair. One is 1 minus tan x, the other one is 1 plus tan x. So whenever you see a conjugate pair involving tan, what you need to do is you need to convert this into tan a minus b. If this is minus, then we are going to convert this into a minus b. If this is plus, we are going to convert this into tan a plus b formula. So look at this. What is tan a minus b? The formula is tan a minus tan b divided by 1 plus tan A tan B. So that is why I'm telling you, the moment you see a trigonometric function, don't start differentiating unless and until you simplify it. Is that clear? Now what basically I have to do is I have to convert this expression into this. So look at this. Instead of tan b, I got tan x, no problem. But instead of tan a, I got 1. So I need to change this. That's the first thing I need to do. Now just go below denominator. You see 1. 1 is already there. So you see tan b, and instead of tan b, we got tan x. And in front of tan b, we got tan a. That means in front of tan x, what do you see? There's nothing, means I can take it as 1. So I have to, instead of these two, I have to write these two as tan of some angle. So in class 10 you have learned that tan 45 is 1. So how can I replace 1 in terms of tan? So instead of 1, I can easily write tan 45 minus tan x divided by 1 plus, again instead of 1, tan 45 into tan x. So what do you get? Y equal to under root, what is this? Tan A minus tan B divided by 1 plus tan A tan B. What is that? That is tan A minus B. So tan, which one is your A? A is 45 minus x. Now you simply have to differentiate this. You simply have to differentiate this. So I hope you understood the concept. Now differentiate. Derivative of y is dy by dx. What should be inside the root? X. So derivative of root x is 1 by 2 root x, that is tan 45 minus x, but this is just an assumption. So d by dx of tan 45 minus x, so you're left with 1 by 2 under root tan 45 minus x into, you can you tell me what is the derivative of this tan 45 minus x? See, this is 45, isn't it? So you know that tan should always be with x, so we assume this part as x. So derivative of tan x is, you know, it is sec square x, that is 45 minus x, but this is just an assumption. So d by dx of 45 minus x. So when you simplify this 45 minus x, what will be the last end result? So what do you get? See everyone, when you multiply, you get sec square 45 minus x divided by 2 under root tan 45 minus x into, derivative of 45 is a constant, so derivative of 45 is 0, minus derivative of x is 1. So 0 minus 1 is minus 1. Minus 1 into this will give you a minus sign in front. Is that clear? So this was a very important question. In the previous case, you saw a conjugate involving cos. So 1 minus cos x and 1 plus cos x. So you know what you're supposed to do. And this is a conjugate involving tan, so you need to convert this into tan a minus b. Once again, the formula for tan a minus b is tan a minus tan b, 1 plus tan a tan b. So I want to rewrite this into this form so that I can write tan a minus b. So when you compare, you see that I just have to replace the value of tan a. So what's the value of tan a? 1. And what's the value of tan a? 1. So instead of 1, I can easily write 1 as tan pi by 4. So now this becomes tan a minus tan b divided by 1 plus tan a tan b. Is that clear? So that is nothing but tan a minus b. After that, I have done the substitution. Okay, now what I want you all to do is, everyone, please write down page 203. Okay, if anyone does not have a maths book, I will send the picture of the questions in the group also. So from there, you do all the questions from this particular question number, that is question number 9. Is that clear? Question number 9. So tomorrow we are going to do few more difficult questions from this. So if you have any problem with what was taught today, please feel free to ask. Is that clear? Okay, just go through this. If you have any problem, you can let me know. So I'll be sending the what do you call, the picture of the question that has been done. So I want you all to do question number 9, and I'll just tell you a few more questions. So please don't let it pile up, just complete it right now. You still got 7 minutes left, so please complete it. Okay, so good night everyone, see you tomorrow.